Hello, everyone. Good night today too. Thank God for another day. We are all blessed, and I'm sure I'm blessed. I'm blessed, and you're also blessed by the grace of God. Today we'll be having a lesson on C++ programming language. That's a modern language that was brought out of C language, the language C. Language C. Before that, let me introduce myself. I am Emmanuel Asare. I'll be taking you through these lessons for about 5 to 6 or let's say 7, 10 weeks. Now let's dive in. In this chapter, our learning objectives we will first focus on introduction to C++, or you'll be introduced to the C++ language. You learn why you use C++ or why you should learn C++. You will know the difference between the C++ language and the C language. You also learn object-oriented concept of the C++. You learn the standard library component like the input-output stream. As you continue with the objectives, you also understand the C++ language development process flow. You also know the difference between the process and threads of the language. You will explore C++ programming in code blocks. That's when we are dealing with the practical aspect. You know the code blocks, the type of code blocks that you should download, the ones that you use for, and how everything works using code blocks. By the way, we have other the IDs that you can use for the C++. Some will use the Visual Studio. It's also a nice ID. You can also use the code block. Some you have the Note, the Note plus something. Now let's begin with our lesson. Our lesson on C++ language. Let's first start with the history about the language. And for the history, someone will be like, what is C++ actually? And how did it come into existence? Yeah, well, I'm here to give you some small history about the language. So first, you be like, it was created by a scientist, computer scientist, who is named Bijan Strup in 1979. As you can see, it's highlighted here. Bijan Strup in 1979. The language was first or formerly called the C language with the classes. The C with the classes. C++. The plus also means make it better. Yeah, something like make it better. It was actually from the C language. It was evolved from the C language. It was coined by Rick Massity in 1983 and it was commercially released in 1845, as you can see on the slide. In mid-1998, the ANSI and the ISO C++ language standard were approved. So let's move to why we should use the C++. Someone will be like, why am I supposed to learn the C++ language? Or what actually am I going to use for? Why should I learn it? Why am I learning in school? It's not my field. And why should I know about all this? So let's focus on it. C++ is used in every computing system, efficient, close to the machine programming system programming language. As you can see, someone will be like, first, C++ is used in virtually every computer system you can think of, from your smartphone to the biggest supercomputers. There is C++. Always C++ works in all these computing systems. Then the second, C++ has object-oriented programming, which is sometimes short called OOP. The OOP will be like, oops. You add the S, it sounds like, oops. That's not what you're talking about. So it's incredibly efficient and close to the machine language. The C++ is close to the machine language. This means C++ programs can run very fast and use computer resources effectively, very effectively. That's the C++ language. It is what we call a system programming language, which is in the point 2. We have system programming language. It's perfect for building operating systems, games, and high performance applications, the C++. And the third, we have object-oriented programming. That's the C++ object-oriented programming. We will explore in details as we move on to the down. As we move on, we will explore what's the OOP, the object-oriented programming, and the OOD. That's it. So this makes it easier to organize and manage complex programs. And the point 4, we have C++ is a compiled language. C++ is a compiled language. This means your code gets translated into machine language before it runs. This makes it faster. That interpretation and other languages move fast. I hope you understand what you are saying. The next point, we have universally usable modular programs. It's a portable programs for various platforms. It allows you to write modular programs that can work on various platforms, like we have the Windows, Mac, Linux, and more. I mean more, like a lot. Well, let's move to the object-oriented program. As I said, this is our next slide, object-oriented programming. We'll be dealing with object-oriented programming. For short, is the OOP. As I said earlier, it might sound complex, but let me explain it using a simple analogy. But first, let me give you what's on the slide. Is identify components called objects, specify relevant data and possible operations to be performed on that data. Each object consists of data and operations on that data. An object combines data and operations on the data into a single unit. Let me break this down for you. Someone will say, imagine you are designing a car, any type of car that you want, or your favorite car. Imagine you are designing your favorite car. In traditional programming, you might write separate pieces of code for the engine. You want the engine to become big, like you want it to work perfect. So you write separate pieces of code for that engine, the wheels, the steering wheel, and so on. The same for object-oriented programming. You create objects that represent real-world things. Hope you understand what I'm about. So you would have a car object that contains all the data about the car, like its color, the speed, the fuel level, along with all the operations you can perform on it, like start the engine, accelerate, brake, etc., etc. It will be like etc. Each object combines both the data and operations that work on the data into a single unit. This makes your programs more organized, easier to understand, and easier to modify. That's it. So as we continue with the object programming language, we have a programming language. It's also a programming language that implements OOD. The OOD is object-oriented programming language. It's also an object-oriented programming language, the OOD. So we are continuing. Then the next point, we have learn how to represent data in computer memory. That's how to manipulate data and how to implement operations. So also write algorithms and implement them in a programming language. So let me break it down and break what's on the slide down for you. When we say a programming language implements OOP, OOD, we mean it provides tools and features that make it easy to create and work with objects. It provides tools and features. You understand the tools and features as we move on that make it easy to create and work with objects. As you learn this C++ language, you discover 3 important things as well. And the first, you will learn how to represent data in computer memory. It's like learning how to store information about your car object, as we said earlier. Use that thing as an example. Second, how to manipulate the data, like changing the car speed and fuel level. Yeah, as we use that as an example also. Third, you will learn how to implement operations, like the actual code that makes the car accelerate. You also learn to write algorithms, which are the step-by-step instructions for solving problems, and implement them in the C++ language. You have types of algorithms also, so that's the flowchart and I think the pseudocode. That's flowchart and the pseudocode. As you continue with the object programming language as well, you will learn how to combine data and operations on the data into a single unit called an object. C++ was designed to implement the OOD, object-oriented design. The OOD is object-oriented design. It's used with structured design. Let's break this slide down I hope it is self-explanatory. Let's move on to data abstraction. Data abstraction, that is the creation of classes to describe objects. Data encapsulation for controlled access to object data. We also have inheritance by creating derived classes, including multiple derived classes. Let me break this down a bit. First, data abstraction. Let's say data abstraction. Data abstraction. This means creating classes to describe the object. A class is like a blueprint. If you want to build cars, you first create a blueprint that shows what every car should have and what it should be able to do. What every car should have and what it should be able to do. And you have the encapsulation for controlled access to object data. So for the encapsulation, this means controlling the access to object data. Going back to our car example, you don't want just anyone to directly access the engine. They should use the ignition key. That's the encapsulation. So encapsulation works the same way in programming. And our third point, we have inheritance by creating derived classes. Inheritance here allows you to create new classes based on existing ones. If you have a general vehicle class, you can create car, truck, and a motorcycle. Classes that inherit common features but add their own specific characteristics. I'll be getting. We are still continuing. We are now polymorphism. Yeah, that's the Greek for multiform. That is the implementation of instructions. That can have varying effects during program execution. That's polymorphism. That's a polymorphism. Polymorphism. It means the same instruction can have different effects depending on the context. For example, if you tell different vehicles to start, a car starts its engine, a bicycle doesn't need to start anything, an electric vehicle starts silently. Same instruction, different implementations. Yeah, this makes your program more flexible and easier to extend with new features. So this is a simple programming C++ program structure. C++ program structure. It's a simple one. We have the hashtag include IOStream, using namespace std, int main, then you open the bracket, cout, enjoy yourself with C++, and then end line return 0. We'll be talking about this as we move on. But first, let me explain some few lines to you. When you talk about the hashtag hash include IOStream, that tells the computer to include a library for the input and output operations. Think of it as important tools that you will need. That's it. That's the hash include IOStream. Then using the namespace std, that's also like saying I'm going to use the standard set of tools. So I don't have to write std throughout the code to make your code clumsy and other stuff. So you just use this tag or using namespace std. That's the second line. And we now come to the int main. The int main is where your program starts executing. Every C++ program must have a main function. So the int main is the main function of the C++ programming language. Now we have the cout. Cout is used to display text on the screen. It outputs the text on the screen. We will do practical sessions in our week 2 and week 3. For now, I'm just giving you the basic knowledge about the C++ so that you will love it and join me in our next lecture. And then we also have the less than symbol, which is a less than symbol, 2 symbols. They direct the text to the output. The end line means you are ending the line there. This here is highlighted. It means you are ending our line. And the return 0 tells the program has finished successfully. That's it. Let's move to our processing the C++ program. Processing the C++ program. Now let's understand what you want to run. Let's understand what happens when you want to run a C++ program. It's a step-by-step approach that we all use. So to execute a program written in a high-level language such as C++, you use an editor to create a source program in C++. In a C++ program, statements that begin with the symbol hash are called the preprocessors. As an example is the hash include, as we did here, the hash include IOStream. It's called a preprocessor. It's called a preprocessor. So these statements are processed by a program called preprocessors. So also use the compiler to check that the program obeys the rules. The program obeys the rules. It's also translated into machine languages, which is the object programs. We have the software development kit, that's the SDK. May be used to create a program also. So finally, you might use the software development kit or SDK, which provides additional tools to help create a program. Let's continue with our slides. As you continue with the processing, you're talking about the linker, the loader, and the execution. The linker, the loader, and then execution. So here, we will say the linker combines object program with other programs provided by the software development kit. Software development kit to create executable codes. That's the linker. The linker combines or compiled program with other programs provided by the SDK to create executable codes. Just think of this as gathering all the pieces you need to run your program. That's the linker. Now you come to the load. The loader loads executable program into your main memory. And the last step is to execute the program. So the loader then loads the executable program into the computer's main memory. Then finally, you execute the program or run your program. This is when you see your program actually working. I should have done some practicals for you to see. But we'll be doing all these things in our next. So these are the processes. These are the structure from the editor, preprocessor, it moves to the compiler, linker does its work, the loader, then execution. Let's move to compiling and linking. For the compiling and linking, it's something like you run the code through the compiler. If compiler generates the errors, look at the code and remove the errors. You run the code again through compiler. If there are no syntax errors, the compiler generates equivalent machine codes. The linker links the machine code with system resources. I'm just reading the slides for you. You can just sit down, read this. You get an understanding from here. This is like the quality control manufacturing. First, you run your code through the compiler. The compiler finds the error, like typing mistakes or incorrect syntax, to generate error messages for you. When you see errors, don't panic. This is normal. Like every programmer makes mistake. Simply look at the code, fix the errors, and run it through the compiler again. If there are no syntax errors, meaning your code follows all the C++ programming language rules that you've learned, the compiler will generate another equivalent machine code. This code that the computer can directly understand and execute. Then finally, the linker connects your machine code with system resources, creating a complete and runnable program for you. You can just read, you understand. Let's move to the loader and executing. As we continue, once your program is compiled and linked, the loader can place it into the main memory for execution. So this is like loading a game into your console before you can play it. So once compiled and linked, the loader can place the program into the main memory for execution. Then the final step is to execute the program. The compiler guarantees that the program follows the rules of the language. It does not guarantee that the program will run correctly. So the final step is like executing the program. That's when your code actually runs, and that's what you programmed it to do. Here is something important to remember. The compiler guarantees that your program follows the rules of the C++ language, but it doesn't guarantee that your program will run correctly. You could have a program that follows all the syntax rules, but still doesn't solve the problem you wanted it to solve. That's why testing is so important. As a scientist, test and evaluation is always important. Now let's move to our next slide, as we call the process. So now the process is a program loaded into memory. The process is a program loaded into memory along with all the resources needed by the program. Each running instance of a program is a process. Each process runs independently. Let me break this thing down like it's self-explanatory, but some will say they don't understand. Let me break it down for you. Now let's talk about the processes. A process is simply a program that has been loaded into memory along with all the resources it needs to run. Think of it this way. Your C++ source code is like a recipe. Yeah, when you compile and run it, it becomes a process, like actually cooking the meal using that recipe. Each time you run a program, you create a new process. If you open the same program twice, you have two separate processes running. That's why I said each process runs independently. Now, let's move to threads. A thread, understanding thread. Thread is a unit of execution within a process. Multiple threads can be initiated from a single process. There are single-threaded process and multi-threaded process. That are the types of the thread. The thread is a unit of execution within a process. If a process is like a restaurant, then threads are like the individual workers in that restaurant. This is particularly important in modern programming, where we often want our programs to do several things at once, like playing a music while downloading a file while responding to a user input. Yes, that's a thread. Now, visual representation of the thread. This is a visual representation of the thread. The process, we have the thread. The time execution is also there. Oh, wait, let me give you some time. Time execution is also here. Let's continue. Thread and process in programming. The program starts out as a text file of programming code. The program is compiled or I'm reading the slides. The program is compiled or interpreted into binary form. The binary form, the zeros and ones, we all know. The program is loaded into the main memory. Everything starts with a text file containing your programming code. This is what you type in your editor. Your program is compiled, interpreted into binary form. The binary is the language you know, zeros and ones that the computer understands. Then your program is loaded into your memory where it's ready to run. Threads and processes in programming language. As you continue with it, the program becomes one or more running processes. Processes are typically independent of one another. Threads exist as a subset of a process. Threads can communicate with each other more easily than process can. So they have their own memory space and resources. Within each process, threads exist as subsets. Think of threads as different tasks that the process can perform. Yes, here's the key point. Let me give you the key point. Threads can communicate with each other more easily than processes can. This is because threads within the same processes share the same memory spaces. They all share the same memory spaces, while processes are also isolated from each other for security and stability reasons. Oh, sorry, and that brings us to the end of our first lectures. Thank you for your attention. I look forward to seeing you in our next lecture, which is a week 2. I encourage you to do more practicals. Join me for our